So if I got to number 1 and I said, okay, I want to try and work this out, and I go to try to type it in the calculator, and I get this error message. Well, how am I supposed to do it then? What can I do? Yeah, we got to pull an I out. So, pull the I out, makes what's underneath become positive, and then what's the square root of 81? 9. So 9i would be my answer. And yeah, if you wrote I9, I'm not going to complain or say that's wrong. But notice that's just it. There's no plus minuses with these yet. When I get to 3, 4, 5, 6, and those, I have to pay close attention to whatever's in the middle. If it's plus or minus, I'm just combining like terms like I would as if it were a variable term. I don't have to multiply until there's nothing in between. So here, all I'm going to do is go ahead, 4 minus 7 is negative 3. Watch your signs. Negative 9 plus 5 is negative 4i, and that's it. Again, keep life simple. To me, the only thing that could possibly get us somewhere here in 3 through 5 is this guy. Because people forget that minus goes all the way through and not just to the 12. So it changes the signs on my 12 and on that negative 3i. And then all I've got left is to combine the terms that are alike. Okay, and I'm set. I can't combine the negative 7 and the 16 because this has got an I and this doesn't. So that'd be all I could do on that one. 5, lots of distributing to do, but at least there's no minus here to deal with. That's nice. Again, make sure you distribute to both terms inside the parenthesis, not just the first one. So I get that distributed through. So 21 plus 6 is 27. Negative 14 minus 24. Think about money on this. Don't mess this up. It's not two negatives as a positive because we're adding. If I owe somebody 14 bucks and I borrow 24 more, I owe them 38. Okay, again, just combining like terms so far, so not too bad. When I get to 6, though, now it ramps up a little bit. Yeah. So when I get here, I've got to FOIL this out. Now, I've had some people tell me, you know, I kind of get confused when you start doing this because you're like, okay, so here's my first, and I multiply that. And then I'm starting to draw all these lines. 2 times negative 7's negative 14i. And some of you, I mean, and I understand this. You're like, there's too much chaos. There's too much confusion with all of this, all of these lines going everywhere for me. We're going to finish this one off now. We did it that way, this way, but I want to show you an option that I've got for you here in a second. Now, hopefully that'll help some of you out. But one thing before we get there. What's I squared equal? Negative 1. So what this really means is, if this is negative 1, negative 21 times negative 1 just changes the sign on it. And that's all we're really doing with that. Because then I have like terms. 8 plus 21 is 29. Negative 14 plus 12 is negative 2. And I'm set. Now again, if that's not your idea of, yeah, too many lines and things. Okay, here's your other option. if you want to do this and make sure you're organized and you're not losing parts, got kind of like an organizational tool, I guess I'd call it. And what I do is I take each set of parentheses and I put them around the outside of my box, and then I just multiply what's on the edges of each part as I fill in the box. And when I get done filling it in, I've got the same terms that I'd have if I'd FOIL, and then I could just combine the things that are alike like we did here and make the change. So if you need something that's a little more focused for you, maybe think about using that as an option, because you'll get the same answer at the end anyway. So just something to ponder. What if I have a fraction and there's i's in the denominator? Can I just cancel these i's out? Unfortunately, no. It doesn't work that way. But we do have a way of being able to get that out of there. And it's called, again, multiplying by the complex conjugate. It sounds so hard, but it's really just a very minor thing. Whatever sign's in front of I, we're going to change it. So if this would have been 1 plus 3i, I'd use a minus here, and vice versa. But I have lots of foiling to do again, just like we did over here, except I got to do it to the top, and then I got to do it down in the denominator as well. So again, depending on how you feel comfortable. If you're comfortable just working it out or doing the lines, that's fine. If you're not, it's not a terrible idea. And I'm going to do my work kind of off here to the side again with my sticky note to say, okay, I'm going to do a couple of these box things. And again, you've got some room at the top of your paper too if you needed some extra space. So I work this out. Multiply. And I multiply each place to fill my boxes in. Once I've filled my boxes in, I go back for a second before I start writing this down, and I say, okay, I squared is -1. We remember that from before. So 3 times -1 would be -3. So the top of my fraction, I've got 5 minus 3 is 2. And 15i plus 1i is 16i. And then I'm going to run that same thing when I do the denominator, except if I do it right, I shouldn't have any i's left. It should just be a number at that point. So I'll peel this one for a second. And I'm going to do this one more time. And again, it's about getting it right. It's not about doing it 100 miles per hour to get done. You're going to have plenty of time to do this quiz. So it's not like we have to be in a rush. 1 times 3i is 3i. 1 times -3i is -3i. And -3 times +3 is -9i squared. But again, I squared is -1. So -9 times -1 makes it a +9 that I'm going to be working with. And then my last job is to sit here and say, okay, 1 plus 9 is 10. Hey, -3 and +3i wipe each other out. Good. I don't have any i's left. But am I done? Well, kind of, but kind of not. I don't have any I left in the denominator anymore, which is a good thing. But does any number divide into all 3 of these? 2 does. So I need to divide all of those by 2 to get to my final answer. So like if this were our quiz tomorrow, this is probably going to be like a 2 or a 3 point question. If you got to here and forgot to reduce, you'd lose like 1/2 a point out of 2 or 3. So it's nothing terrible, but we don't want to lose the mini points, okay, whenever we can avoid that. So that's something we want to ponder. Let me move this up a little bit. Okay. So then we get to solve. I see x squareds. Reminder. Okay, two answers. Usually going to be something with plus minus. So I start looking at this and I go, okay, must isolate x term before I do the square root. Must isolate. Okay. Even when I get here, I see the 64. I want to do the square root now because it's a perfect square. No. Isolate. Isolate, isolate, isolate. Now that x squared is alone, now I can go in and do the square root. But there's a couple of things I got to remember. Oh, I got to remember plus minus, and you're right. I have to take an I out. But wait, there may even be a little more. Can I break down the 32? Be careful, because I know what some of you are going to do. You start thinking about your perfect squares, and you know what? It may even be a good idea for some of you tomorrow. As soon as you get your quiz, maybe you start jotting some of these down just to kind of remind you and get you thinking about it a little bit. I need two numbers that multiply to 32. One of them has to be in the list, and the bigger the better. 16 and 2. Because if I'd use 4 and 8, which is legit, I'd have to do it a second time. So square root of 16 is 4. That gets to hang out with my I. But the 2, unfortunately, does not break down anymore. Okay, I get my two answers. I pulled my I out. I broke it down. Lots of little things to remember, but nothing's too terribly awful. Now, the only time that changes is if we start seeing parentheses. I still need to isolate the parentheses, though. So how do I get that negative 3 out of there? Okay, we got to divide because we're multiplying here. Let's see here, 45, okay. I do not want to FOIL this out. I do not want to distribute the squared. Once I get here, the only way to get to that x is to square root it. Those guys get wiped out. Plus minus. Pull my I out. You know my next question. Does the 45 break down? I'll give you a hint. Yes. What number from my list is a factor of 45? 9. So 9 and 5. Square root of 9 is 3. So that gets to hang out with I. And the 5's still underneath. Now, here's my last step, and this can be the doozy for some people. You're like, what's so doozy about it? I got a -1. That's not the tricky part. How do I write this, though? I can't combine it with this. That plus minus is like a blockade there. It's like, okay, -1, you can hang out on this side with me, but don't try to get all comboed in here with me because I won't let you do it. So that's the best I can do for an answer on that one. So that'd fix that up. And then finally, solve. Got to get x squared alone. Minus that 81 out of there. Now it's isolated, square root it. We're going to take this all in at once. We got this. Plus or minus. I know to pull out an I. What's the square root of 81? 9. No radical at all left. That's nice. And we've got this, okay? And we just kind of keep working through these, but it's like any Algebra 1 problem. Isolate that x squared, and then we'll just square root it instead of just being done like we would with one of those. Okay? Solve by completing the square. Okay, we got this. X is alone on one side. Check. B value, my B value is 10, whatever number's in front of x. B value divided by 2 and square it. That's what I'm going to add to both sides. So I'm just going to use a little blank here, because unless some of you have colors, it may not jump as much as you may like. So it'll just remind you, whatever we add to one side, we're adding to both. So once I do that, get that out of there. I don't need my computer restarting right now. And I go, okay. Now we're going to turn it into that binomial. And remember, I get my number that goes with x by taking whatever my b divided by 2 number was, that positive 5. And now basically we have a problem that gets finished off just like we finished off number 9. Once we had the parentheses by themselves. Take my square root, gets rid of the squared because they are inverses. No I this time because there's no negative to deal with. But what can I use to break down 27? 9 and 3. Okay, the 9 breaks down. Can't lose my plus minus though. 3 square root of 3. And then my last job is to minus the 5 over. And again, I know there are lots of places where something can go haywire on you. But again, it's not about speed on these. It's about just taking your time and treating it like you would any equation. What do I got to do to get x alone? Okay, what's the next thing I've got to do? And just do it in pieces, and you'll get there. So my only difference between 10 and 11 and 12, and I'm going to do the first step with you, but then I'm going to cover this up for a second. I want you to try this one on your own. I got to have just my x's together on this side. So I got to get the 20 out of there, so I'm going to minus it over. Now, for a moment, I'm going to cover this up. So what I want you to do is, taking the steps that you saw us do over here, I want you to try and finish off number 12 on your own. And I'll get the actual answer up in a minute, but I want you to take a moment to try and do that. So hopefully, as you are working your way through this, I will give you a heads up. For some of you that may be further along than others, your radical is not going to break down this time. So if you're sitting there and pounding away and going, I got to break this down, it's got to break down. It's not going to this time if things have gone correctly. I'll give you a couple more seconds here just to clean up a couple of things, and we'll see if you've got things going well here or what's happening. Again, take a look. If something went haywire, you know, it could be a lot of little things. Maybe you forgot about this 7 being negative in here and you put x plus 7, okay? That's an easy enough thing to fix up. Or maybe you forgot to add the 49 to both sides. But if you've got that, great, you're right on it, okay? And if not, you're going to get another chance to see it here right now because we're going to do it to help us with a circle. So, okay, circles. Completing the square twice. Job 1, we're going to get anything that isn't x and y to the other side. So first, variable terms only on the left. Then, I got to get my x's together, and I got to get my y's together. Because my next step, I have to have them separated. Okay, so x is together, y is together. And now we basically are just going to do the process that we did up here for x, and then we're going to do it for y. So when I do it for x, take my b value, my number in front of x, divide it by 2, and square it. So I've got x squared plus 8x plus 16. And I'm going to leave myself some space here because I'm also going to add that to the other side where my 24 is. And then I'm going to run the process one more time for y. My b value is -6. Divide that out and square it. And I'm going to add that 9 to both sides. So it's really no different than when we were doing it in numbers 11 and 12. It's just now I've got to do it that one extra time. So I get here and I'm like, okay, what do I do next? Oh yeah, I'm going to go to binomial form. So x +4, square that. And then for my y's, y, my b divided by 2 was -3 squared. And then we just add these guys up, 40, 49. Okay. That's the form I need to get the information I'm being asked for. Identify the center. Okay, just change the signs on these. -4, +3. And then to get my radius, I just take the square root of this. And I'm set. So again, it's just a quick process with completing the square to do it. You just got to get used to it a little bit. And if you haven't practiced, well, this gives you an opportunity now with examples to have something to go back and do the practice with to make it a little bit easier. All right, area of a rectangle. How do I find the area of a rectangle again? Thought I heard it. Maybe I didn't. Length times width. So they give me all the info. They give me the area, and they give me the length and width. So basically at this point, I multiply this through, and again, x times 3x is not 4x. I'm not adding, I'm multiplying. So it's 3x squared. X times -5 is -5x. And I'm going to have to factor this. So I want to minus the 152 over. Now, I'll be honest with you at this point with what we've learned. You have an option now. If you don't want to factor this, and it might get ugly for us for a little while, but we're going to get there, you could use the quadratic formula to try and do it that way. So I'm just saying, it's an option, okay? I'm going to factor, though. You're like, oh, Harty, there's nothing that comes out. These are going to be ridiculously huge numbers again. I know, but we're going to fight through. We're going to get there. Okay, I'm going to get my little side work ready to go here because you know how this works. We're going to grab us the calculator, and we're going to start playing. Now, here's one thing I do know. These numbers are going to need to be 5 apart from each other. So really me doing stuff with like 456 and 2, okay, doesn't help me a lot. But here's what I can do to try and make this a little better. Let's say I divide that by 2 again. You're like, okay. And then maybe I divide that by 2 again. You're like, now what did I just accomplish? Here's what you just accomplished. If I multiply these together, 2 times 2 times 2, that'd be 8, right? It's going to start helping me shrink this down a little bit. Because now, maybe I get to a little bit bigger of a number. I'm looking at 57, and I'm like, well, I know 2 doesn't go in, but I think 3 does. Okay, so 8 times 3 is 24. I just multiplied those numbers together. I've been dividing. Wait a minute. 24 and 19 are 5 apart, Harty. Yes, they are. Notice I didn't have to punch in numbers for an hour. I just had to kind of play the game. So let me show you that one more time to kind of speed some things up for you when you get really big numbers. If you try something small, okay, just make yourself a little list. You're like, okay, so 2, and try to keep dividing it by little numbers. Okay, times 2. I'm not really getting, oops, no, I don't want that. Until you get to a point where you're like, okay, 2 times 2 times 2 is 8, so I'm at 8 and 57. Now I'm going to try to make that 57 get smaller. So you try a number like 3 or 4 or 5, and when you do that, then you can be like, well, that was 8, so now I timesed it by 3, so that's 24, 19. And you can start to shrink the big things down in a hurry, so you're not doing this forever. So you're like, okay, I'm done with hearing about you talking about forever. Let's do this. Okay. 24 and 19. One's going to be positive and one's going to be negative. How do I know which one's which? If I want them to add to -5, which one needs to be the negative? The bigger one. And we've done all this outstanding work. Don't blow it now. Don't forget the divide part. 24 divided by 3 is 8. 3 does not go into 19. So it swings back to the front. And remember, I'm actually trying to get a value this time. So I set these each equal to 0. Add my 8 over. And keep reminding yourself, this is the side of a rectangle that I'm looking for. One of those two values I found is sensible for being the side of a rectangle. The other one isn't. Which one's sensible? Okay, the 8 is a negative side. That doesn't make any sense. So x is 8, and then the dimensions in my triangle are found by plugging that back in and finding the answer. Now again, I'm telling you, it can get frustrating when you're up here because you're playing with these numbers. You're like, oh my gosh. If you start getting frustrated, go past that problem and come back to it, okay? Because the numbers will work. You just got to keep playing with it a little bit. It's just something to ponder. Okay? Rewrite in vertex form. You must show work. In other words, we're going to complete the square again. So, now I got to remember back a little bit on this one, how this works. Oh yeah. Vertex form. Here's what I want this to look like in the end. So what I'm going to do, here goes my process again. Take my b value, divide it by 2, square it. But remember, this time, we're going to add it to the y side. And then we're going to group off our x's and add it to those. The 20 doesn't disappear, it just gets stuck outside my parentheses. So I'm like, okay, doesn't quite look like this yet, but it's going to in a minute. x. Oh yeah, it's that b divided by 2 number again. That seems to work for all of these. It's because it does. You're like, dang, now I'm almost there. That's the same, that's good. I just gotta have y alone. Okay. So I'll minus the 49 over. Now it's in my form. And I'm a happy camper. But again, I have to know what vertex form is. Because otherwise it gets kind of difficult. And then finally, with a reminder, actually you'll have vertex form because you can use your green sheet on the quiz tomorrow. Because we're doing focus and directrix a little bit again. You're like, dang, we're back to the parabolas again. That's okay. Standard form. We're going to use the calculator for a lot of this, but I got to do this one step by myself. So to find my x, we almost are there. Stay with me, people. The opposite of b, the opposite of negative 4 is 4, over 2 times a, 2 times 1, which is 2. That's the only thing you have to do on your own for this problem. Everything else is absolutely capable of being done on the calculator. I'm going to go to y equals. I'm going to type this in because I don't want to have to do more work than I have to. Why would I want to do that? And I'm going to go to the chart, or the table. You're like, well, where am I going to find my information that I need? I know that x should be 2. So I want to get x equals 2 in the middle of my chart. Why? Because if I did it right, I should see symmetry. I should see the same numbers going out from the middle, going up and down. And I do, so I know I did this right. So when x is 2, y is negative 1. Got my vertex. Better yet, I also can get my other points from here. So 1, 0, 3, 0. I wish I'd have given myself a little more room here because it would have been nicer to see more of the parabola, but that's okay. And I graph it. And I'm good. So that wasn't so bad. I needed to just deal with this one little thing. So not too shabby there. Vertex form. Vertex is already here for me. Change the sign. Keep the sign. 2, 3. My axis of symmetry. Oh, I'm going to be nice on this and put the x equals. Just the x equals my vertex. They always go together. But again, let the calculator help you with the rest of the graphing part. So I've got negative x minus 2 squared plus 3. Okay, let me get to my chart. My vertex looking good? Yep, because I see symmetry. So I'm going to let the calculator get me the rest of the points that I need to make my parabola. So the only thing mathematically I'm going to have to do for this whole problem is the focus and directrix. So I'll give you a quick reminder, but again, you can use the green sheet. So focus, reminder, is h k plus 1 over 4a. You're like, okay, what's all this stuff again? My vertex gives me h and k. My a value is the number at the very beginning of the problem. It's in front of my x squared. In this case, it's negative 1. So I've got h k plus 1 over 4a. Here's the only tricky part to this, because I can't quite just slam it into the calculator. 4 times negative 1 is negative 4. If you get to this point, now I can go to the calculator if I'm not comfortable dealing with the fraction. I can just do 3 plus negative 1 1/4. And I don't care if you use a decimal. If you use a fraction, if you use a decimal, I'm happy with either as long as the answer is right. But again, you've got to do things in pieces. Now here's the cool thing about the Directrix. That's going to be faster. Because the Directrix is y equals k minus 1/4a. It's the exact same thing you just did here, except now it'll be 3 minus -1/4. And again, you can do that on the calculator. 3 minus -1/4. 3.25. That's fine. So it's okay to use the helps that you have. It's just got to know a couple of things. With the green sheet, you don't even have to know it. You just got to be able to look at it and copy. So again, not terrible. Not terrible, not terrible, not terrible. And finally, solve by factoring. I'm going to write this on every single thing we do with factoring until this does not become a problem anymore. Before you try anything else, do they have anything in common? I have so many of you on 18 that would start sliding and dividing right now. You don't have to slide and divide on this. We're going to make this easier. What do 3, 15, and 72 have in them that's divisible in? 3. What's better than 3 making things smaller? It's going to be a diamond problem now. I don't have to slide and divide. This just got made a whole lot easier. Because now all I got to do is figure out what multiplies to -24, which tells me there's one of each sign, and adds to -5. Now again, if this isn't your strength, I want you to make the chart, our little tree graph, and I want you to try to start dividing numbers in. And again, if you're doing this on the calculator, you're just doing like 24 divided by 2, 24 divided by 3, 24 divided by 4, until you get yourself a list working. Because if you do the list, now I just got to go back through and say, okay, which pair adds up to this? That equal -5? Nope. -5? Nope. -5? Nope. -5? Oh yeah. So -8, +3. Great job on the factoring. Solve it. Don't stop. Don't lose a point you don't need to. Set it equal to 0. Don't set the 3 equal to 0. There's no variable with it. Get the answers. You're like, okay, 19, anything in common? I can't divide something out, no. But I should recognize something here. What's 81 and 49? They have something in common, but not something that divides in. What type of numbers are they? Perfect squares. Again, I'm going to keep barking. You've got to know those perfect squares up to 10, because you look at this and you're like, okay, I squared 9 to get 81. I square 7 to get 49. You cannot add 49 and square root. It says factoring. Sometimes we're going to force you to use a tool. So each get a 9x, each get a 7. But since I want them to multiply to a negative, one gets a negative and one gets a positive. And then I just set them equal to 0. And get my answers. And again, I'm going to put my answers as fractions. If you put them as decimals, I'm not going to tell you it's wrong, as long as it's the right decimal. But again, you'll have the whole period tomorrow to be able to work through this and then turn in any homework. And then we'll see how things are going. Unlike what I had mentioned yesterday,